Okay, so we're going to be doing chapter 8, which is quiz 1, the first review quiz in my book, Overcoming Digital SAT Math. So just as a disclaimer before I start, make sure that if you have this book for the best results to attempt doing this on your own first, and then coming back to this video after you've also attempted corrections on your own to look at any explanations for stuff that you may not already know how to do or can't figure out how to correct. Also, I want to note that some of the questions are not in a typical digital SAT format, just because if I felt like there was a more efficient way to ask something, I did. Like, for instance, in every single quiz, I added a mean, median, and mode question, like this one, and range, because you're definitely going to get a question similar to this. So, but you don't know if it's going to be mean, median, mode, range, that sort of thing. So I figured that would be a good idea, even though it's technically asking you 4 at a time, to just kind of throw stuff like that in there. So, let's start with number 1. So it says the table displayed below contains the age groups of the total population of men and the number of registered male voters in Turkey in 2022, rounded to the nearest million. In 2022, the number of registered male voters was n% of the total population of men. What is the value of n? Round your answer to the nearest whole number. Okay. So registered male voters is in total going to be 87, because they didn't say it was for a specific age group or anything like that. So we're talking about 87 million. 87, I'm going to put mil for million, over, and then the total population of men that we're picking from, which would be 244 million. Now, you can cancel out the millions. You could have written out all the zeros if you wanted to, but if we're talking about 87 million over 244 million, we could just cancel out the million and just look at it like this. And then we could times that by 100 to get the percent. So let's just put that into a calculator really quick. Because remember, on this version, whoopsies, I'm using a computer calculator, so it's going to be a little slower, guys, sorry. On the digital SAT, you have access to Desmos the whole time, or you can bring your own calculator. So when you do that, it's not going to be exactly a whole number. That's why it says round to a whole number. So it's going to be 35.6557, and it keeps on going a bunch. So we have to round it to the nearest whole number, which would be 36. So that's your answer. Okay, so now for number 2, it says, for the figure above, all labeled angles are in degrees. What is the value of B plus C? Write your answer without the degrees symbols. Okay. So remember, in a triangle, if you add up all 3 angles in a triangle, you should get 180 degrees, right? We want to figure out what the value of B plus C, so this angle plus this angle, is here. We technically have 2 triangles right here. We have this little triangle portion here, and then we have this big triangle portion right over here. So let me just look at this really quick. So that means that, let's call this X and Y, just to label the other angles. So that means that 120 plus X plus Y has to equal 180 degrees. And then it also means that if we were to do 67, the degrees right there, 67 plus this whole entire angle and this whole entire angle right here, we should get 180 degrees. So if we just want to isolate X plus Y here, all we have to do is subtract 120 from each side. So then we're going to get X plus Y is equal to, if I subtract 120 on each side, 60. So now, instead of X plus Y over here, I can just put 60. Now remember, all we want is B plus C. So I can combine my like terms here of 67 and 60 to get 127 plus B plus C equals 180. Then, if I want to solve for this, like the question's asking, all I have to do is subtract 127 from each side. And then when I do that, I should get B plus C is equal to 53 degrees. Thank you guys for the likes and shares. So let's keep going to number 3. Which of the following expressions is equivalent to this? So you see how there's like this little exponent of 2? That means that the whole thing inside the parentheses is squared. Another way we could write that is that we have x squared plus 16 times itself. Like this basically means that we have this. And then plus, and then I'm just going to copy over the x minus 4, x plus 4 portion. Now remember, whenever we have two or more terms added or subtracted inside a parentheses times 2 or more terms added or subtracted inside parentheses, we have to do something called foiling. So FOIL is an acronym that stands for what you're going to multiply. So F stands for I'm going to multiply the first things together, so x squared times x squared, which is x to the 4th. O stands for I multiply the outer, so 16 times x squared, so 16x squared. I stands for I multiply the inner, so 16 times x squared. Again, 16x squared. L stands for I multiply the last thing, so 16 times 16. I don't know that off the top of my head. So 16 times 16 is equal to 256, which I should know that with how much I do this, but whatevs. So now we're going to do the same thing, FOIL, for this portion right here. So x times x is x squared. 4 times x is 4x. Negative 4 times x is negative 4x. And then negative 4 times 4 is negative 16. Now we're going to combine our like terms. So over here, I see I have 16x squared plus 16x squared. And then over here, I also have an x squared term. So these are all like terms that I can combine. So I'm going to copy over x to the 4th. And then I'm going to say, okay, well, 16x squared plus 16x squared, that's 32x squared, plus another x squared is going to be 33x squared. And then I'm going to say, okay, I'm going to look for other like terms. I see that there's like terms right here, 4x minus 4x, but those cancel out to 0. And then I see that I have like terms here of 256 minus 16. So then that's going to be plus 240. So which one is that? That would be answer choice C, right over here. Okay, so now I'm going to erase this so it doesn't get all messy and like mixed up with the next problems. Really quick. Okay, so number 4, we have a system of equations has infinitely many solutions. If one of the equations in the system is this, then which of the following could be the other equation in the system? So remember, when you're talking systems of equations and they say either infinitely many solutions or like no solutions, like impossible, no solution, you're gonna, as your first step, try to make each equation in the system look as similar to each other as possible, whether it's the no solution or infinitely many. So that's what I'm going to do because it says infinitely many solutions. So I'm going to see, okay, this is one of my equations. One of these has to be the other. So which one of these can be manipulated to look like this equation right here? And I see right away, let's see, I think the only one that I'm seeing is D. Yeah. With D, I can multiply this entire equation by -5. And if I do that, I'm going to get the exact same equation I have up here. So if I have the exact same equation over and over again, like in my system, I have the same line. So if I graph it, they're going to be right on top of each other at every single point. They're going to have infinitely many solutions. So it would be answer choice D right here. So then let's go to number 5. So for number 5, it says f of n is equal to this, and then for that function, f of k minus 8 is equal to 0. Assume k is a constant. What is one possible value of k? Okay, so remember, whatever's inside your parentheses right here for your function, ooh, I don't like that did that. Whatever's inside your parentheses here is going to replace what's inside your parentheses in the main function in that same place next to the f. So k minus 8 needs to replace every single n value up here. So that's what I'm going to do. Everywhere I see an n, I'm going to write k minus 8. So then I'm going to say f of k minus 8 is equal to, and then instead of n, I'm going to put k minus 8, and then copy over that minus 2. Over here for n, again, I'm going to put k minus 8, and then plus 7 squared right there. Now remember, the problem said that f of k minus 8 is the same thing as saying 0, so I can replace this whole part right here with a 0. And then I can simplify these portions right here. So for the first set of parentheses, I can say, okay, minus 8 minus 2 is going to be minus 10. So k minus 10. And then over here, minus 8 plus 7 is just minus 1. So I can say I have k minus 1 squared. So we know that this is being multiplied by this, and it has to equal 0, meaning that one or more of these factors has to be equal to 0 in order for it to get an answer of 0. Like when you multiply by 0, like one of the things you multiply has to be 0 to get 0, basically. So I can set either of these equal to 0. I can say k minus 10 is equal to 0, and then add 10 to each side and get k is equal to 10. I could also do k minus 1 is equal to 0, add 1 to each side, and then get k is equal to 1. Either of these would be acceptable answers because it's just saying what is one possible value for k. They didn't specify like which one you had to pick. Now, what they might do on the exam as like a variation of this type of problem is they might say, oh, assume that k is a constant greater than 5, for instance, and then you know, oh, I have to pick 10. If they said something like that, then you would only have to pick between like the one that's fits the rule they give you, but they don't do that here, so you could just pick either one and it would be okay. Oops. Wait, is that a speck of dust? Sorry, I'm like OCD. Actually, though, I'm not being offensive. I actually have OCD. Okay, so then let's go to number 6. What value of x satisfies the following equation right over here? So remember, one thing that you can do real easily so that you don't have to work with icky fractions is to just multiply by the lowest common multiple, which of the denominators, which if we're looking at 6, 3, and 2, the lowest common multiple, the lowest number that they multiply out to would be 6. So I'm going to multiply this whole thing by 6 so I can cancel out the denominators. Well, 1/6x times 6, the 6's cancel out, so it's just x. And then if I do 1/3 times 6, 1/3 of 6 is just going to be 2. And then if I do 1/2 times 6, that's just going to be 3. So then I just subtract 2 on each side, and I get x is equal to 1. So now let's go, oh my god, what is that? Shoot. Go. Sorry. There's like a pigeon by my window that keeps like bothering me. Okay, so now let's go to number 7. Line M has an x-intercept at k over 3 is equal to 0 and a slope of negative 6/7. Which of the following is the y-coordinate of the y-intercept of the line M in terms of k? Okay, so basically they want to know what is y specifically for the y-intercept. So remember, it's a line. So any line, we can use this formula that we're used to. And then this is going to be what they're basically asking for. That's the y-coordinate of the y-intercept, or you could just think y-intercept. That does not say is equal to. What is equal? Did I say something wrong? Sorry, I was distracted by the pigeon. But this is basically a line. We know it's a line, so we can use y equals mx plus b. So our slope is represented by m, so we can replace m with negative 6/7. So replace m with negative 6/7. And then whenever they give us a point, they give us an x comma y. So when they told us k over 3 comma 0, they told us x can be replaced by k over 3 and y can be replaced by 0. So that's what I'm going to do. I'm going to say 0 is equal to negative 6/7 times k over 3 plus b. And then now I just need to cross cancel. 3 goes into 3 one time. It goes into -6, -2 times. So then I have 0 is equal to -2k over 7 plus b. I want to solve for b, so I'm going to add 2k over 7 to each side. So then that's going to give me 2k over 7 is equal to b. So the answer should be b. You said k over 3 is equal to 0. Oh, yeah, sorry. I was, like, distracted for a second. This pigeon keeps on, like, sounding like it's dying outside my window. I do not have experience with pigeons, so I didn't know they make those noises. It's weird. Okay, so let's go to number 8. So we have this quadratic right here, and we want to know a possible solution to the equation shown above. Thank you for sharing the live. So quadratics, when we want to find the solution, we can factor, or we can do quadratic formulas, typically what you want to do, one of those two choices. But if you look at the answer choices, you'll see that there's radicals involved, meaning like a square root or like some type of root, this symbol. So that indicates that I should probably just go ahead and do quadratic formula because it's not going to factor nicely. But before I do quadratic formula, I have to set the quadratic equal to 0. So I'm going to do 2x squared minus 14x minus 13 is equal to 0. And now I'm going to figure out, since the quadratic formula says that x is equal to -b plus or minus the square root of b squared minus 4ac over 2a, I have to figure out what a, b, and c are based on this, and then just plug it in. So a is going to be the number that's multiplied by x squared, b is the number being multiplied by x, and c is the number off by itself. So now I can just easily plug those in. So negative of b, so the negative of -14 is just positive 14, plus or minus the square root of, that's going to be -14 squared minus 4 times a is 2, and then times c, which is -13. And all of that's going to be over 2 times a, so 2 times 2 for a. So then now what I'm going to do is I'm going to simplify all this that's inside the square root. So I'm going to do -14 squared. And I'm going to use my calculator just to, because I can do that on the digital SAT. So that's going to be 196. And then it's going to be -8 times -13. So that's going to be positive 104. So plus 104 right there. And then all of that is 2 times 2 is 4. So all of that over 4. So now I have x is equal to 14 plus or minus the square root of, if I add all that up, that's going to be 300, not 200. That was a terrible 3. 300 over 4. Someone asked why is it plus or minus, because that's what the formula indicates. So we're plugging in a, b, and c based off of the quadratic formula, which this is the formula for it, which includes a plus or a minus. It says like you could plus or minus this. So now what I'm going to do is I'm going to say, okay, how could I break this up into factors to simplify it so it looks more like one of these answer choices? Well, 300 I know can be 3 times 100. So then we're going to say, okay, this is a perfect square, 100. So I can take that out and as a 10 because 10 times 10 is 100. So that's what I'm going to do. I'm going to take that out. So then now I'm going to have 14 plus or minus, and I'm taking out the 10 and then leaving the 3 on the inside. That's supposed to be a 3 over 4. And then now I just have to simplify by saying, okay, what's the greatest common factor? Well, it's going to be 2. So 2 goes into 4 2 times, and then 2 goes into 14 7 times. 2 goes into 10 5 times. So it's going to be 7 plus or minus 5 root 3 over 2. So we have to look for one of those solutions because you could have it being plus or minus is what it says. So we have to look for one of those. So 7 minus 5 root 3 over 2, so it would be A. Or which graph represents the following situation, or equation, sorry. So we have this equation right here. Now what you can do with this, there's different ways to solve it. Whenever you're matching a graph to an equation, You can just plug in points from the graph to see like what's correct if you don't know things like parent functions or the characteristics of quadratic functions, that sort of thing. But obviously that's going to be more time consuming. On like a time test, it's not what you typically want. So it's fastest to say, okay, I'm going to think about the characteristics of quadratics because I see that this is in vertex form. The formula for vertex form of quadratics looks like this, where h comma k is going to be your vertex. So knowing that, I'm going to say, okay, I'm going to find out what the vertex is, my h comma k, from this equation right here. So my h is going to be 2, and my k is the number out here, 3. So I need a graph that has the minimum value being 2, 3. I need a graph that has the minimum value being 2, 3. So let's see if we can figure it out just from that. So A, that's not at 2, 3. Let's look at C. That's at negative 2, 3, which is not what we want. We want positive 2, positive 3. This is not at 2, 3, so it can't be that one. But over here, it's at positive 2, 3 as the vertex or the minimum value, which is correct. So D is the correct answer there. So then let's go to number 10. For the figure shown below, point G in the center of both circles lie on FH, or point G in the center of both circles lie on FH. Okay. Assume the ratio of GH to FG is 1 to 5. If the area of the shaded circle is 84, so this area, 84, then what is the area of the unshaded region? So we want to know the area of all this white space right over here. And then, sorry, I got a text. So let's say they told us the ratio of GH to FG is 1 to 5. So I'm going to say that this is X, the GH part is X, and then the FG part right here is going to be represented by 5x because that's a 1 to 5 ratio. Okay, so if this whole diameter right there is x, and we know that the area of that circle is equal to 84, and remember, area of a circle, the formula is, that's supposed to be pi r squared. Let me rewrite that so it looks nicer. Area is equal to pi r squared, pi times the radius squared. We can input the information that we have. 84 is the area, and that's equal to pi times the radius squared. Well, we have the diameter, x, so that means the radius is just half of that, so it's just going to be x over 2 squared. And then, so that's the area of the smaller shaded portion. And let's set up an equation for the area of the big, or the entire thing, because if we have the area of the entire thing, the entire big circle, and then we subtract out the area of the smaller one, we can then figure out what the area of the unshaded portion is. So the area of the big is going to be pi times the radius of the big one squared. So if you think about it, the entire diameter of the big circle is 6x, because 5x plus x is 6x. So 6x divided by 2 would give you the radius, and that's just going to be 3x. So then radius squared would be 3x squared. And that's how you would find the area of the big. And then we just have to do area of the big minus 84, which is the area of the small right there. But in order to do that, we first need to figure out what x is, which we can easily do from this formula, or this equation right here. We could solve for x. So I could say 84 over pi is equal to x over 2 squared, which x over 2 squared is just going to be x squared over 4. So then I could say, okay, I'm going to multiply each side by 4. So then I'm going to have 4, I could probably fit that. Move it over. Okay, 4 times 84 over pi is equal to x squared. Now I could square root this, but I'm not going to do that because it's going to be easier to just use it in this format, and I'll show you why. Because look, if you look at the area of the big one, I mean, you could square root it if you want to, but if you look at this formula, the area for the big, If I start doing the 3x squared portion, this is just pi times 3x squared would be 9x squared. So then I just have 9 pi x squared. So if I figure out what x squared is, which I already have, I can just plug that in, like this in, for x squared. And then I have the area of the big. So this would just be 9 pi times 4 times 84 over pi. Then I can cancel out the pi's easily. So then I just have 9 times 4 times 84. So let me just do that in my calculator because I don't feel like doing that right now. All out. So let's do 9 times 4 times 84. So that's going to be 3,024 is the area of the big. So remember, the question was asking for the unshaded portion. So we're going to do the area of the big, which we just found, 3,024 minus the area of the small, which we know is 84. So it's going to be 3,024 minus 84, and then that's going to give us the answer to the question. So let me just do that really quick. And that's going to be 2,940 as our answer. So let me just erase all of that. And let's go to number 11. So for number 11, assume h of t is an exponential function. The value of h of t decreases by 30% for each 1 unit increase in the value of t. If h of 3 is equal to 24, then which of the following is the correct equation for the function h? Okay, so right away it says that it's an exponential function and it's decreasing by 30% for each 1 unit increase of t. So if it's decreasing by 30%, that means you're left with 70% each time. So there's different variations of this formula. I refer to it as like the rate you're multiplying by. So like that value, the however much is left is 70%. So that value in here needs to be 70% as a decimal, which the only options that give us that are A and B. So we have to cross out C and D because you're basically multiplying by 70% each time. And then what you can also do is plug in the 3 for t and then the 24 for like your h of t value. And then you could see which of these is correct. So let's do that for A. So for A, we have 24 is equal to 24 times 0.7. And then remember your t is going to be 3 in this case. And then if we plug it in here, we're going to have 24 is equal to 24 times 0.7, and then your t is 3, so it's 3 minus 3, which is 0. Now, obviously, the first one, A, is not going to get you to 24, but remember for part B, or answer choice B, anything to the 0 power is just 1, so this is just going to turn into a 1, so 24 times 1 is obviously 24, so it's going to be B. Or 3 plus 3, oh, yeah, sorry. I meant to put 3 plus 3 for the exponent A. Yeah, 3 plus 3 is 6. Whoopsie, thank you for catching that. Okay, so let's go to number 12. Number 12, which of the following is equivalent to this expression right here? Okay, so we have like our, what is it called, law of exponent stuff. So you see how it's like a decimal value? This is what trips people up when they have like a fraction as or a decimal instead of a fraction as the exponent. So all you have to do is remember, okay, negative 0.5 is the same thing as negative 1/2. Wait, A. Malcolm A. What are you talking about? Oh, number 12 you're saying. Oh, okay. I was like, it's not A for the other one. Did I miss something? Okay. So then x squared times y to the negative 1/2 is the same thing as just putting that decimal in like fraction format. And then students are usually able to figure it out from here. So remember that when you have a fraction as an exponent like this, you can, well, first let's use the, sorry, I got off track trying to figure that out. So hold on, let me regroup. So first I want to try doing negative exponent rule, then I'll apply the fraction as the exponent thing. So negative exponent rule says that we're going to put this portion right here on the bottom, but to the positive version of that exponent. Now let's work with the y to the 1/2 on the bottom, and let's use our rule for when we have fractional exponents, which says the bottom is telling you what type of radical you have, so that bottom 2 means you have a square root. And then the top number tells you, hey, that's the exponent you're raising your variable to on the inside of that radical. So y to the first power, which we don't write to the first power, so it's just like y on the inside, so root y is what that is. And then we would have x squared on top. Now, most people get to this point and they're like, I don't see my answer there. Well, that's because we don't like having radicals on the bottom in math, so you have to rationalize it by multiplying by root y over root y to get rid of that issue. So then it's going to be x squared times root y over root y times root y is just y, so then the answer would be A. Okay, so now we're at number 13. Oops. Okay. So for number 13, we have this function for the equation shown above, which of the following represents all values of x for which the graph of the function is above the x-axis. So just so you can like see a picture, this is what they mean, like up here, above the x-axis. So you're just going to basically plug in values and try to plug in values strategically in order to see if they end up with g of x being in one of these quadrants above that are above the x-axis. And what I mean by like strategically is like, for instance, A says that we have x is greater than -1, and D says we have that x is less than 5. So there are a bunch of numbers that can fall like in between those. So like, for instance, let's say that we pick x is equal to, I don't know, x is equal to 6, we'll say. X is equal to 6 is technically greater than -1, but it's not going to be less than 5. So like that's an instance of like using strategy to kind of not pick something that would fit both. Like you don't want to pick like 4, for instance, would work for A and D, so that's not as strategic. So let's now go and plug in 6, and let's see, okay, so g of 6 is equal to 5 times 6 plus 5, so that's going to be 30 plus 5 is equal to 35, so you're going to have a positive y value, which is what you want, like one of these quadrants which will have a positive y value, so that works out. And then now you're going to do kind of like the same thing for the other ones. This would be much faster, like on test day, obviously, because you're going to be doing it in your head. So then I would pick something like maybe, I don't know, 0. Well, 0 is going to work for that one and that one. So then I would probably pick, let's try like, I don't know, -5. -5, if I have x is equal to -5, I'm going to put that in everywhere I see an x, so then 5 times -5 is -25, plus 5, that's going to be equal to -20, that's a negative value, so that would be down here, a negative value for y. Now, -5, that would be a value that's less than -1, so I could cross out that one. It's also a value that's less than 5, so I could cross out that one, then I'm just left with A and C to choose from. Okay, so now let me think, what's a number that is that would help me eliminate one of these. Let's see, what could I pick? Hold on. Let's, that's working for both of them. That, yeah, hold on. 1 works, 2, 3. Those are all working. Hold on. What could be something that doesn't work? Oh, wait, hold on. Oh my God, I can't believe my brain sometimes is crazy. So a value that's going to be working for A but not going to be working for C is going to be that x is equal to, let's say 0. That's an easy one. And then we could just plug that in. I was looking at like this. 5 times 0 plus 5. So then that's going to be a positive value, so that works for that one, but x equaling 0, it does not apply to like this x is greater than 5 situation, because like 0 is not greater than 5. So it would be A. Sorry, my brain's not braining right now. What time is it? 6:36. Okay. So then let's go to number 14. Number 14, in a random sample of 300 phones, 4 have a manufacturing defect. At this rate, how many of the 15,000 phones will have a manufacturing defect? Okay, so we have a directly proportional relationship right here. So we have 4 with the defect. So I'll just say like D for defect, 4 with a defect out of the 300 total phones. And that has to be proportional to like the X amount of ones with a defect out of the total 15,000 phones in the situation. So all you have to do is cross multiply. So I would do 4 times 15,000, which is just going to be 60,000, is equal to 300x, and then I just have to divide by 300 on each side. I could also just like cross out these zeros, which is kind of like the same thing, and then say, okay, what is 600 divided by 3? Well, that's 200, so then it would be B. Okay, so let's go to number 15 right here. The density of a particular sample of raw material is equal to 506 grams per cubic centimeter. If the sample is in the shape of a rectangular prism with the dimensions of this, then what is the mass of the particular sample in grams? So we want the mass in grams. And we know that the density is 506 grams per cubic centimeter. So if we can figure out the volume and multiply by it, we can get rid of the centimeters cubed unit and just be left with the grams, the mass. So I'm going to do 0.7 times here, let me write it out. 0.7 times 0.5 times 0.2 is going to give me like how many centimeters cubed, like the volume. Then I'm going to multiply that by the density to cancel out centimeters cubed and just be left with my gram units. And then when I do that, let's see, I should get 35.42. So now let's go to, let me just erase this and this. Now let's go to number 16. So we're trying to find the mean, median, and mode and range of this data set right here. So let's go ahead and start by putting them in order, which you don't have to do that for like things like mean, mode, but like it's helpful for median and range to do that. So I'm going to start there. So I'm going to say, okay, I'm going to start with the lowest value, 89. You could also do greatest to least. 89, then I'm going to do the next one, 92, the next one, 93, 94, and then 94 again. And then I'm going to do 98. And I like to cross them out as I write them so I don't like accidentally double up on one of them when I shouldn't. So now I have it written in order from least to greatest. So I can easily figure out what the median is, which means like the middle value when you order it from least to greatest, but you'll see there's 2 values in the middle, 93 and 94. When that happens, you have to add them up and divide by 2 because you're taking the average of those two middle, of those two middle numbers. So when I do that, I get 93.5 as my median. And then range is just the high minus the low. So range would just be, or max minus min, however your teacher taught it to you, 98, the high minus the low, 89, which is going to equal 9. So now let's look, mode is probably the next easiest one to do. Mode is the one that occurs most frequently in our list, so 94 would be our mode. Ooh, that's supposed to be an E for mode. And then for mean, that's just the sum of all of these data points divided by how many data points we have. So mean, we're going to get by doing 89 plus 92 plus 93 plus 94 plus 94 plus 98 over 123, 123, 6 total points. So you would just plug that into the calculator, and then the mean would be equal to 93.33 is where you would cut it off, because you're allowed 5 characters for the SAT if it's positive and 6 characters if it's negative. So that would be 1, 2, the decimals 3, 4, 5 characters.